All right, guys, gals, peoples, welcome back. So as promised, I'm going to take this puppy apart and I'm going to move these magnets so that the poles are facing inward. So north will be facing north to create a super north. South will be facing south to create a super south. And I have some magnetic film. I actually have a small piece like this that I 3D printed um, uh, a case for it, but I think I have a bigger one somewhere. And so I'm going to, per G law, I'm gonna take a look at that. But I'm really interested in that super pole positioning. So yeah, I'm gonna get this guy apart. I really love the way that thing spins. I'm going to get it apart because, again, it's not glued. I'm also got not a surprise, but I'm going to build a new Newman motor. But my Newman motors in the past have always been, I've got a Newman motor housing. So they've always been made out of PVC and stuff like that. I'm going to 3D print this one, and it's going to be big. It's going to be like almost 200 millimeters in diameter, about as big as I can print. In fact, I'm printing the center portion now that's going to hold the two bearings. And it's going to take a while because I have to print all the sections separately, and then I will glue those together. But yeah, and I'm going to figure out how to wrap it so that it's wrapped really nicely, not, not just haphazardly like this, even though this doesn't look too bad. Um, and I'm going to use um, large diameter wire. I think that's what I did with this one. I used pretty large diameter wire. I think this is like 20 gauge or something. But yeah, I'm going to do that. I'm really excited about that. And I'm going to try different ways of running the Newman motor. First, the classic way where you just use a commutator and you figure out the timing. And then I'm going to see if I can run it using the JL94 circuit. I don't know if it's going to work, but I'm going to give it a try. So stay tuned. First, I'm going to reposition these magnets and then get this guy set up and see if it makes any difference. First, what I'll do is I'm going to put some reflecting tape on there. I know this is not going to be an accurate test, but I'm going to put a piece on here and a piece on here, fire this thing up at exactly, 12 volts and see what kind of speeds I'm getting running it off of this guy here. And then when we do the super pole, do the same test. All right? All right. Stay tuned. So I put tape on the big cylinder and then tape up there. And if I run it, I got about 8,000 RPM. All right, right now it's only recording 6,000. I got it 8,000 before. I was getting a reading off of this guy, but then it wasn't working. This is saying 1,400 RPM, but that's not right. I think I got to change the battery in this. There we go. 7,200 RPM. Yeah, I think I got to change the battery in this. Yeah, 1400 RPM for the... Now it's... Oh, wait, what am I saying? Not 1400. Yeah, 7,000. Yeah, it's not getting it. Let me see if I could. Yeah, I think I got to change the battery in that stupid thing. Yeah, let me do that, because when I first ran the test, when it was going up slowly, it was grabbing it, and it said it was like 8,000 RPM, and that's when I was reading it off of the base, off of the actual puck itself. So and that's at 12.5 volts. So let me replace the battery and see what we can do. I replaced the battery. Let's see what we got here. So that's 1100 RPM. Yeah, 1100 RPM. And then up here, wait a minute. Why is it? All right, there's 1300 RPM. Yeah, I'm getting inconsistent readings up there. Down here, I'm getting pretty consistent readings. So I'm just going to do it down here. So there's 1400 RPM. Yeah, so that's at 12.5. So I'll leave the voltage exactly where it is. So we'll call this 1400 RPM. All right. Stay tuned while I switch the magnets for this thing to wind down. So it's making that noise because it's rocking on the platform. If I go like that, you don't hear that. Oh, actually, I stopped the noise. I had to pull it over. But yeah, it takes forever for this thing to wind down. There's no power going into it. It's got a fantastic flywheel effect. I mean, it'll go like this for quite some time, because it is a heavy beast. Little zen rotor moment. Really quick, all right, let's just take a moment to appreciate the fact that these threaded rods are 3D printed. They came out really nice too. The nuts too. Come on, focus you. Yeah. I love the fact that I'm using 3D printed threaded rod to hold the sky coil on there. Just take a moment there. I mean, just look at that. That's beautiful. All right, y'all, anyway, welcome back. So I'm in the process of taking this apart, and I can't find my bigger magnet film, but I just wanted to show you, as you can see, let me see if I can, as I move it around, that white line is the separation between the two poles. All right, so north is facing in, south is facing out, south is facing out, north is facing in. And it's funny because the poles connect all the way around, which I didn't know, which I didn't realize, which is kind of amazing. So instead of there just being a separation here and then the pole going around like this, it actually connects all the way across. As you can see, if I can get it in there with here, let's see if I can. Yeah, there. So now I'm going to take this top plate off and I'm going to rearrange them, and then we'll take a look and see how that looks. So welcome back. So in handling this, again, I realize why it has a tremendous weight. So the flywheel effect is really pronounced with this, because this thing is heavy. I should really weigh it. But that's why when I spin it up, and then shut down the power, it continues to spin for minutes. Anyway, you can see I've got all the poles marked. Now I've got to slide these out and turn them, which I'm going to put gloves on. I'm not going to repeat what happened the last time. I tore my finger up right there, and then also on my thumb. You really can't see it on the thumb because that's really calloused up. But yeah, I'm not going to repeat that again. So stay tuned. All right, so thank goodness I wore gloves. So the first one was a disaster, but then I figured out how to do it by sneaking it in there like that. So now the poles are, as you can see, are now facing out. So now, in theory, I have super north, super south, super north. All right, so I've got to admit that I made this pretty good. The tolerances are really tight, so there's no slop in any of those magnets. Of course, I got to level them all out. But yeah, this is a heavy beast. So now I just got to get the rod back through and get it mounted. All right, so welcome back. I've got the super pole set up. It's balancing on. I haven't put the the shield around it yet, but I'm going to. That actually went surprisingly well. I didn't hurt myself. I've got all the magnets are kind of level. There's a couple of them that I need to fix, but yeah, now it's super poles. Look at that. That is cool. Yep, that's cool. So got these super poles. Can't wait to see what they'll do. And put a little light on the subject. And I wanted to show you where I am with my Newman motor. So these aren't glued together, obviously. And I'm building more of these rings. So instead of trying to print it all out in one giant thing, I'm printing it out in sections. So I'll put at least probably 2 more high this way and 2 more low that way. So 4 more on there. And actually what I'm going to do is I'm going to print some flat rings that are going to go on either side of this to hold the wire contained, and then obviously flat ring on the top. But yeah, I've been printing those out, so that's going to be cool. But let me get this guy going again. So I started putting it back together, and I realized I forgot to put the shield on it. But then I started looking at it, and I'm thinking that might look really cool without the outside shield. But I know I need to do an apples to apples test. If I do this, there's going to be a lot of wind resistance, a lot of resistance because there's no shield on there. So I think after I do the test, I may take the shield off because that kind of looks cool, right? All right, guys, so welcome back. So I've got it all set up now with the super poles. And ironically, when I put the film here, it shows the two. It doesn't show anything in the center there, but that's definitely where the pole is because the pole reader, this little guy here shows it. So if I go like that, that's a south, that's a north. It doesn't really record straight on because of the 2 poles. So I definitely have super poles going. I broke my screw. I was just bragging about it a few minutes ago when it broke, but it's holding it tight enough. So let me get this going. Still at 12.5. And let's see what we can get going here. 360, 390, 400, 500. It's beefing up there. Now we're at 600. Come on. 700, 800, It's definitely flying. I don't remember what, so now we're at 1,000 RPM, still climbing. $1,100, 1,200. Still climbing. I think we're going to get to 1,300. Yeah, this is definitely going much faster than the way I had it set up, and it's still climbing. $1,380. Oh, now it kind of lost it. No, yeah, so now it's going too fast. Yeah, it's going too fast. Come on, get back over here. So I think the super poles make a difference. What I need to do is take a reading. What I forgot to do on the other one was to take an electric reading of the output. But I think I'm going to go with the super pole from now on, because that thing is flying. So thanks guys for the suggestion. Yeah, two of them, G-Law, which is now Magnus Attractus, and Toffee Flavor, both said something about super poles. I think G-Law told me a long time ago about it, and I didn't pay any attention to it. And we're still getting our floating, or our maglev. Yeah, she's really flying nicely, putting out a solid stream. So it works really good, guys. Now I'm gonna have to try some different coils, take some output readings. But yeah, it's working great. 12.6 volts. All right, thanks for watching. So welcome back really quick. So I've turned off the power. And this is the flywheel effect I was telling you, because this rotor is so heavy. It is still flying. And it's going to take quite a while for it to wind down. That is one heavy ass rotor. You can hear it winding down, but it doesn't, if you're looking at it, it doesn't appear to be winding down, even though I know it is. Straight through there. I also want to try to see if it makes a difference if I put my sky coil horizontally instead of vertically like this. But yeah, that's a tremendous flywheel effect. All right, guys, so thanks. Looking back over the previous video when I had the poles normally, I don't know if I was taking the reading correctly, because I don't think it was doing 8,000 RPM or 6,000. I think it was doing, yeah, I'm not really sure. Regardless, I'm going to go with the super pole method. I think this works out really well. Just wanted to throw that in there.